What's going on, guys? Let's try this problem right here. This question is asking determine the standard and general equation of a plane containing the points, and we have these 3 points. And in order to find general equation, we have to have a normal vector, but it's not provided. But it can be achieved by taking two component vectors and cross multiplying each other. So here, to get the component vector, what we are going to do is we are going to tell this is P, this is going to be Q, and let's say this is R, something like that. Now let's say we want to find two component vectors, so let's take PQ and PR. Now PQ is basically we subtract P from Q, so this is going to be Q is what? That's -3, right? So we are going to have -3 minus, so we subtract P from Q, right? So -3 and P value is 1. We only subtract like terms, x with x, y with y, and z with z, like that. Now -3 minus 1, and Q has 4. 4 minus 1, that's going to become +1, and -1 minus 2, that's going to be -1 minus 2, and let's simplify this one. This is going to become -4 plus 5 and -3. Okay, -3, and this is one of our component factor, actually component form of a vector. And then we had to find PR. Again, now we subtract P from R. R value is 3 minus P, that's going to be 1, and then -2 minus -1, that's going to be -2 plus 1, and 2, actually 5 minus 2, and this is going to become 2 minus 1 and 3. And now we have found out two component form of vectors. Now we have to do cross multiplication in order to find the normal vector. So let's go ahead and do the cross product. This is going to be V times W, and in cross product what we do is we put ijk component first, and then we are going to put one of this thing, that's going to be -4, 5, -3, and here we are going to have 2 minus 1, 3, and then we are going to use cofactor expansion method to cross this one. Now cofactor expansion method, we put plus minus plus, right? If you remember, the first equation is going to be plus, and in the plus, like when we take this one, all the values here will disappear, right? This y-axis and the x-axis of this one will disappear, so we only left with this part. That's going to be 5 minus 3, 2 minus 1, right? And plus minus plus, so second one is going to be, we have to put a negative sign, and this is also I right here. And second one, when we take this one, all the y and x components eliminated, we are going to left with -4 minus 3, 2, 3, right? Now this is our second one, and this is in the j direction, and the third one we put plus, right? Third one we put plus and k component, and if we take k, if we eliminate the k y-axis and x-axis, we are going to left with -4, 5, 2, minus 1, and this is in the k direction. Now what we have to do is we have to do AD minus BC multiplication, A, B, C, D. So you can see AD minus BC is this cross minus this, right? AD minus BC. Now let's do that for each of them. 5 times -1, that's going to be -5, and 2 times -3, that's going to be -6. -5 minus minus 6, so minus 5. Okay, there is a mistake I made right here. This one is 3, right? Because if we eliminate I, y component and x component of this vertical and horizontal component is I, we are going to have 5 minus 3, negative 1, 3. So this is also negative 1 right here. And then let's double check everything. When we take j component, minus 4, minus 3, 2, 3, this is correct. And k component, minus 4, 5, 2, minus 1. Okay, this is also correct. Now let's do the cofactor expansion method. Now what we have to do is AD minus BC. 5 times 3, 15, minus, so this is going to be minus 1 times minus 3, that's going to be plus 3. 15 minus plus 3, that's going to give us 12 in the I direction. And then we are going to have minus 4 times 3, that's going to be minus 12. 2 times negative 3, that's going to be 2 times negative 3, negative 6. So minus 12 minus minus 6, that's going to be minus 6, but here we have a negative sign in front, right? So that's going to make this one positive 6, and that is in the j direction. And then negative 4 times negative 1, that's going to give us 4. 2 times 5, 10. So 4 minus 10, that's going to give us negative 6 in the k direction. Now we have found out our normal vector. Now we can go ahead and write our this general equation, but first we have to write the standard equation. Now after we found out this one, we can get rid of some of the parts because we need some space. Let's get rid of these things. Okay, so in order to solve this problem, we need a normal vector and a point. We found out the normal vector, right? So normal vector is 12, 6, minus 6, and you can choose any point for the point vector. So here we are going to choose this one. Let's choose this one. 1, minus 1, 2. Now we have a normal vector and a point. Now we can express this one in standard form of the plane's equation, like standard form of a plane equation. So in this case, what we are going to, the normal vector is going to be outside of the equation. But before we do that, it seems like we can simplify this equation a little bit more. Like if it's n, 12, 6 and minus 6, if you multiply this one by 1 over 6, that's going to become 2, 1, minus 1. So this is another way to write this normal vector. This way is better because that will make everything easier, right? Let's write our normal vector as 2, 1, minus 1. And now we can go ahead and write our standard equation of the plane. Our standard equation, we take this value, the normal vector values is going to remain outside. So that's going to be 2 times x minus, and in the minus we put the point vector's value, like for x it's going to be 1, right? And plus the outside we are going to have 1, and then for y we are going to have minus 1, that's going to be plus 1, and for z we are going to have negative 1, so we put a negative 1 in front, negative 1, and z minus 2. Okay, this is z minus 2, and that is equal to 0. And this is standard form of the plane standard form of a plane, standard equation of a plane. Now we have to find a general equation. To find the general equation, we just simplify this one. Like we just multiply and simplify the form. So this is going to be 2x minus 2 plus y plus 1 and negative z plus 2 is equal to 0. Now we can combine like terms, like we can add the numbers and bring the x, y, z components together, like 2x plus y minus z and minus 2. So here we can see that this minus 2 and this plus 2 cancels. We only left with plus 1. So the general equation for this plane is going to be 2x plus y minus z plus 1 is equal to 0. And that's it. This is our general equation, and this is our standard equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.